Okay, so assalamu alaikum. Good evening, everyone. So let's start. So again, thanks for being here so far, and welcome back to Reinvent Recap. So that's the last session in our 2 days. We started yesterday by Amber talking about network, an amazing session from Paul Maddox about serverless container, and then we had Asif, where Asif was covering the analytics. And now we are going to machine learning. So let me introduce myself. My name is Ahmed Raafat. I'm a solution architect in AWS based here in Dubai for the last 2 years. For the last 2 years. And I'm going to be here with you today talking about an AI and machine learning. So let's start. So first of all, what we are doing here is a recap of reinvent. So feel free to go to AWS/reinvent. You're going to find all the detailed session with a PDF format of the PowerPoint that's being presented, and as well a video recording for more than a 250 session. Definitely, I did all of them for sure. But really, even for myself, when I want to learn something, dive deep in specific topics, that's the place that you go. It's a pretty rich. And even as well, for the previous year, sometime you can go to 2018 and you get a lot of resources from there. So let's go to, that's like a long list for all the sessions. You can see there. So let's go for dive deep in AI machine learning. Before we dive, anyone can recognize this creature? Anyone on the chatting window can recognize this creature? Just type it. Special gift from my side for him later. Anyone recognize this creature? That's not graphics. No, not seahorse. That's not seahorse. And AWS people should not answer. that's a real, it's a see something. It's actually called Sea Dragon. We're gonna use this in one of our demo today. It's a really beautiful creature. It's only you can find it in Australia. So if you are a big fan of diving, that's a creature that you should dream one day to see it. It's a pretty amazing. It looks like a mystery. Anyway. So let's go back to our machine learning and again ask a common question, like actually why we need a machine learning. So I wish this was an interactive session, so maybe we give a more interaction. But that's a lot of question, a common question everyone asking, and people have a different answer for that, like, do a lot of automation, saving costs, increasing innovation, helping humanity, doing a great stuff, all this stuff. But for me, why people move to machine learning is because we are, as a human, we are a quite lazy people. And that's true, right? So we're smart. We try to do things with less effort. And that's why we decided to make machine learning. If you think about machine learning, it's actually something help you to reduce the amount of code that you're writing, right? If you think about, like, you want to do, let's say, classification. So you can do classification with a lot of if conditions with a basic programming, right? But if you have a complex problem, that's going to be taking for you long, hundreds and hundreds line of code. You need to write it down. Think about if you want to do an object detection or image recognition, that's crazy. Like, you cannot write such with a normal programming language that we used to do. And even, by the way, and I guess you're going to be so on the rest of the presentation, that actually we start to feel more lazy. So we are moving from ML to deep learning to avoid a lot of feature engineering. And even we move from deep learning now to things like self-learning, which is something called reinforcement learning, like what we do with the deep racers. And even we become more lazy and moving to something called generative AI. So that's the thing, right? We do machine learning because we're quite lazy. We need to enjoy our time. Keeping joke aside, maybe you think about that, right? So the traditional programming, we used to get data in and you write your own rule and you get the output. In the machine learning, it's the other way around, actually. So you have the data and you have the output in most of the cases. If you are using in machine learning, what we call as supervised learning, right? Where you have your data is already labeled. With that, you are getting all this data, you pass it to the computer, and then, we come up by a rule. And the rule is what they call is a model, right? And simply the model is a trained algorithm. Think about an algorithm is a bunch of equations that you just simply get it from mathematician people that they build it one day. We can argue if they really know what going to be using this equation for or not, but yeah, it end up, but this equation has become very important. We apply this data and we tell them, you know what, this is the output. We adjust this equation, left and right, top and down until we get out of the rules. And that's we call model. And that's simply machine learning. And, we're using machine learning in a lot of stuff. And as this is an AWS recap session, we'll not go in a lot of introduction, but I just want to let you know that's become, very common now for a lot of our customers. It's become reality, and everyone using it every single day. One of the very interesting cases that everyone here in the region is using Aramex, and Aramex is one of our customers that heavily using in AWS machine learning to do multiple scenarios. One of them that you can see here in the slide, where they actually able to increase their productivity by analyzing the shipment and reducing their transit time significantly. And actually, this has reduced the income customers call as well for them by 40%. That's increased the shipment date prediction accuracy by more than 70%. So that's a quick thing about the customer that we are having. And always you need to keep in mind, AWS is putting significant investment and it's a big area of focus for us in AI and machine learning. You can see the company mission on the screen here is that we put the machine learning in the hand of every single developer. And that's a very clear and strong mission we have it. And for that, we build a very comprehensive, if you think from the number of service and the depth as well of the services in our ML stack. So I think maybe most of you saw this slide before. You will not spend so much on this slide, but just a quick brief on this slide. So if you see it's been splitted, it's split here to 3 parts. So the first part in the top, talking about the AI services. It's a bunch of services that's actually built and trained and deployed and continuously trained by AWS. You don't need to be a data scientist. You just need to be a developer and able to read the documentation and understand the SDKs and how you deal with it. And then you can utilize this AI services. And this is going through multiple categories between vision, speech, text, search, building chatbot, and pretty cool services like a personalized forecasting and fraud detection. And as well as we're providing services that enhancing your day-to-day operation, like an Amazon code guru to help you to more clean and easier develop your code, and as well enhancing a contact center through a tool called Contact Lens. So this is again an all AI services. You don't need to be a data scientist or practitioner to do all that stuff. The next layer, as you can see here on the screen, is called ML services, which we're gonna do a lot of details talking about it today, which call with one of our products is called SageMaker. So think about this layer for the people that they are to some extent, you can say that they understand good programming, they understanding the algorithm, they can translate the business problem to an ML problem to choose an algorithm to be utilized. And they want to customize and build and train their problem using a centralized place. And that's what's come to SageMaker, which I can explain it in details. But think about it as something accelerating your journey of building and training and deployment your model. And the last layer is called ML framework. That's mainly for machine learning and data science practitioners. For the people who want to use the frameworks directly and you want to build their own, let's say, neural networks, they want to build recurrent neural networks using most common frameworks in the market like TensorFlow, MXNet, PyTorch, as well as because we want to make a machine learning available for everyone. That means that we need to provide the most common tools for everyone. We cannot make you or enforce you to utilize specific tool. So that's why we're supporting TensorFlow, MXNet, PyTorch, as well as we do a couple of joint research with another cloud providers on the market to come up by something like Gloon, which is an abstract layer in top of MXNet that's help you to an easier interface with the frameworks, or something like Crass, which is actually pretty common people using with integration with TensorFlow, especially TensorFlow 1. A lot of argue now to say like, maybe with TensorFlow 2, you don't need much in Keras. But anyway, a lot of Keras library has been integrated in TensorFlow. And for that, you can still integrate it with SageMaker, by the way, or you can go and get one of our EC2 machines that's supporting and GPU empowered by NVIDIA GPUs, or you can use one of the machine that's INF1 that Paul talked about it yesterday, that use special type of CPUs that and GPUs that help you to enhance your inference time. And inference means simply that the response of your model. When you deploy it in production, you just like send something to get the results. Forget about the fancy words. That's something about the data scientists do it just to make you away from their business. But like, don't feel afraid. It's just like you get your results, send data, get results. That's inference. Anyway, so that's our AWS machine learning stack. So let's dive in SageMaker and see why we built SageMaker and then what we got new inside SageMaker. If you think about the journey of building a machine learning, it's not only just about you run the model or you train the algorithm to get the model out. It's more than this. And usually on the business, on the field, you'll find that the business people expecting from your side to do all that stuff. And it's pretty challenging because your job, it's need to be know a lot of stuff between, you need to know, how to collect the clean data, which we collecting the data and preparing it. You need then after to choose the right algorithm for this problem. And in that state specifically, you maybe try multiple models, multiple algorithms. Maybe from the first time it didn't work. You need to do a lot of feature engineering, cleaning, cleansing the data, which is really hectic and take a long time. Then you need to try a lot of stuff. And then you need to keep record of what you did. Usually, like you need to take a notes from what is the hyperparameter that has been changed, which model that been used, what was the values. And if you are a person like me that just put his note everywhere and it's not organized at all, then you'll end up by a mess. You don't know where you write your data in. So it's pretty challenging, right? And then if you are likely get all of this done, now it's tell you, you know what, you need to deploy it in production. And for you as a data scientist, you say, oh, for me, I'm done. I built my model and that's the results. I don't know what to do after, right? So for that, you need to deploy the model. You need to think even after you deploy the model, how you need to continuously retrain the model because it cannot stay forever in production with the same performance. And if you did actually a great model and you put it in production and, everyone like it and start to hit this model, end of the day, this model is deployed in a machine. And, end of day, unfortunately, this machine can be, overutilized and stuck and hang or whatever. And you end up, but your model is not working your model is not working from data science perspective, actually is not working because the infrastructure is not working and that's not your job. So you need to think about how you do auto scaling of that. So if you think about this, it's a lot of challenges. And actually it's take you away from your main focus of how I can focus more on my ML problem that I'm trying to fix. And likely we have SageMaker. So SageMaker is a fully managed platform. Think about it as something is here to make your life easier, right? So it's help you to build and train and deploy your machine learning. Take you across all the steps that we build it for you. So it's going through all the layers that we discussed in the previous slides, which take you through collecting the data, building your model, training, and deploy it in production. So SageMaker has been announced for more than 2 years now in reinvent 2018. And actually in last year, in reinvent 2019, that we do a recap with it, I would call it actually, instead of reinvent, SageMaker. Actually, there's a lot of things has been announced, has been added in reinvent specifically for SageMaker. One of the key things that we did in reinvent is actually called SageMaker Studio. So think about SageMaker Studio is a centralized place as integrated IDE and it's the first IDE focusing about the data scientist. It's getting everything for you in a centralized place. From you can collaborate with your colleagues, the rest of your data scientists. It's always been a challenge how the data scientists can share their notes, their Jupyter notebooks. Usually they can be in their machines, in a specific EC2 machine or using a different cloud. And even if you're putting in a notebook in SageMaker, how you can easily share that. The other thing is the challenge of trying multiple stuff on that. And you're going to be see this in a live demo that I will do later, is we did something called experiment. If you remember, I told you that usually in production or real scenario, you try a lot of stuff. You try that you get the data with specific features where you can think it's enough initially, but then you may need to go back and add more features. And then you need maybe go back and remove some features or join two features together to come up by new features. So all of these tries, you need to keep track of, as well as there is something weird called hyperparameters, which is related to the equation that you use, related to the algorithm. You need to keep track of all of that. And you need, if you're using neural network, you need to keep track for how many neural network layer that has been used. So a lot of stuff, and you need to write it in a note somewhere. Like, and for me, I used to get like a notebook and write it down. And sometimes I write it in a notebook or write it in a text file. And I don't remember where I write all that stuff. So it's quite annoying, right? SageMaker Studio, getting all this stuff for you in one place and capture this, keeping this information in a ready-made place for you. You don't need to keep tracking about this. Use your SageMaker as your assistant to capture all these details. The other point, or the third icon you see here on the screen, which is called automatic model generation, that's a quite interesting one. And I remember like 1.5 years back, one of the customer came to me and said, you know what, SageMaker is cool, but why he cannot recommend for me to choosing a model? And here we go, with SageMaker Studio, we have something called Autopilot, which is going to be explained it in details, which is actually based on your data, it can recommend for you a model to choose. It can help you at least to save a lot of time to see what's the recommendation come from SageMaker, and then later you decide to build on top of that or use something else. And the other thing as well that we help you with the tools that we can automatically help you to better debugging your model, understanding what's happening inside the neural network, and as well as monitor your model after you put it in production. And the other thing that we always continuously doing as well, that we help you by increasing the productivity and optimizing your model. So we have a team inside AWS. Their job is only optimizing TensorFlow and enhance the performance in TensorFlow on top of SageMaker. So SageMaker Studio is here. We're going to be seeing in the demo. That's a screenshot from SageMaker Studio. if you before work with Jupyter Notebook Labs, it's actually built in top of SageMaker, also Jupyter Notebook Labs. So it's similar interface to some extent with a lot of enhanced features. So you can see your Jupyter notebooks. You can easily build your Jupyter notebooks. You can see the number of trials that you can see here on the right-hand side of the screens and what the results of these trials. One of the interesting stuff that we created on a SageMaker, and we announced it in SageMaker in reInvent 2019, that SageMaker notebook. We used to have something called notebook instance, which you come to SageMaker with one click and say, I need a notebook instance with a different kernels, with Python 2.7, with Python 3, with TensorFlow, with MXNet, and that stuff. And one click, you get this instance up and running for you, right? And you click inside it, you find Jupyter Notebook, and it was pretty cool. Maybe it takes like 2-3 minutes that you get your instance up and running, but it is cool, right? But then the customer came and come to us and said, you know what, we need something easier. I don't need to have an instance. I just need to do one click and I get a notebook. And that's what we did. We have now SageMaker Notebook, which simply with one click, you say, I want to have a SageMaker notebook, and you get a notebook, and you choose whatever kernel that you want to have it inside it. It's an easily can be integrated with a single sign-on. It's a fully managed. This one is an easy to set up, and you can easily share it, right? You come to SageMaker Notebook, and I'm going to show you again. This is in the demo. You get here on the right-hand side, as you can see. You have your notebook. You can see here, there is an icon here. You click on share. It's an icon of like a camera. When you click on it and you click create a snapshot, you get a URL and you share this URL with your the rest of your data scientists. Unfortunately, so far, just to make it clear, that's not a live share. It's a snapshot from what you did, right? So keep this in mind. If you do any changes, you need to take another snapshot and you share it again. There's a lot of requests about like, we can make it live. I hope the product team is working on that and maybe come soon, I don't know. But this is the case now, so be careful from that. One of the nice things that we usually tell the people to do in SageMaker, that when you create SageMaker notebook instance or even notebook now, you're going through 3 stages, as we discussed. You're going through a stage of build, then you go for a stage of train, and you go for a stage of deploy. So when you create a notebook instance, you create this notebook instance, a small instance. You don't need to create an instance with GPU, because usually the recommendation that you write your own Python scripts or your own, trainings or whatever inside this Jupyter Notebook instance. And when you kick off the training job, actually SageMaker is going and create for you on the fly an instance with the configuration that you specify. We copy whatever you decided to do on this instance, and we do the training job, and we generate for you the artifacts back to your notebook instance. That can be a very small machine, let's say T2 or T3. And if you are happy with the artifacts, we are happy with your training, good accuracy, again, you tell the notebook instance from your building stage, deploy this with one command. So it will go, build an endpoint for you, get the artifacts, and deploy it for you. So all of this being done on the training stage and on deployment stage in a different machines, not the machine that you actually building it. But there was always still some challenge that the customer came and say, you know what, during my build stage, I need to clean my data. I need to do data cleansing. I need to maybe need a bigger infrastructure to, let's say, like an Hadoop or Hortonworks, or for us like an EMR, to structure this data in a way that can fit my model later. So for that, people used to do is they create a bigger notebook instance to build, which was costing them a lot. Or actually what they can do is they can call EMR, which is a managed service, as Asif mentioned, for a lot of open source technologies like Apache Spark and Hadoop and that stuff. You can call EMR from SageMaker to do this job for you and get you the results. Still, people feel this complex. So we're happy to announce that we now have Amazon SageMaker processing, which is a GA. So you can start to use it from now. Simply, what you can do, same idea what you used to do with the training, you can still do now this with the building stage. So let me tell you what's this happening. So if I'm getting some data in and I need to do some processing on this data, think about this is before the training, right? So I need to use this on the building stage. So here I need to convert my data to a format that can fit to my algorithm. I need to transfer some feature to a more better format, like using a one-hot encoder, for example. I need to scaling, normalizing my data. I need to handle things like an unbalance in my data, especially if you do like a fraud detection and that stuff. I need to converting some complex address to numbers of GBS coordinates, cleaning the data. So what you just simply do, you dump your data in S3 and you write your own processing script in Python. And you just simply say, you know what, I want to do this job in a specific size of the machine. Like what you used to do on the training, like what you used to do in deployment on SageMaker, you can do it now in the build stage. So you send the script, we provision a machine on the fly, do the job for you, and get you the result back. So in that, you don't need to have a big machine that you build on top of it. Use a small machine, and then on the back, you initiate a processing job, and that's cleaning the data and get you the result back. So let's see the demo. It's been talking for a while. So let's see quick demo about that. So I'm going to be sharing with you all of this notebook instance later. But let's see this one quickly here. So this is my, okay, let's first go to SageMaker. So this is, for the people who have never seen the interface of SageMaker before, this is the interface of SageMaker. So as you see here, SageMaker is being split to 4 stages. We have a stage of labeling the data using a service called Ground Truth. You have here notebooks, you have training, and you have an inference. By the way, there's a marketplace. So if you build a very cool algorithm or something, model, and you want to sell it for everyone, feel free to publish on marketplace. And if you are in a business and you have a problem or something, what you can just simply do is you just like go to marketplace, search if someone built this model before, and you start utilizing it. So pretty cool place to go through. It's really cool. Anyway, so let's see here what I have. So I have here a notebook instance, and I'm using an Ohio region. So I can just simply click and open my Jupyter notebook. And again, just do it slowly. Notebook instance. This is the old way, and I will go for a studio later. How I create this instance, very simple. Click on create notebook instance. Choose the size of this machine. You remember, I'm telling you, use a small size. Don't use the big machines unless you have a reason for that. Put some role and click create. So you will have that, like what I have here. And you click open Jupyter notebook. So you will get this one. So I'll tell you a secret here. You have a golden mine here, okay? That's really a golden mine. You go here, there is more than 200 notebooks that have been written by our machine learning expert for a lot of interesting scenarios that you want to do. So before building from scratch, go here and search for something that you can build on top of it. The most amazing algorithm that everyone a big fan of, XGBoost, going here. And even if you know this model, our team built it in a way that's been optimized with the SageMaker and our machines. So look what they did, right? So you have things here like XGBoost, random cut forest. You have a pretty more advanced scenarios, like, using things like churn prediction, for example, and more models that we're going to be utilizing like today when we talk about hyperparameter optimization, reinforcement, and a lot of more of that stuff. Anyway, let's go back to our problem. So we have here, and this is the model that we are, or like a Jupyter notebooks that we copied to my notebook instance. So I'll click here, and I have here one of my Jupyter notebooks. So I'll click on this one. And remember what we are doing here, that I want to utilize a very small machine that you see it here that I have, which is T2 medium, to process a big bunch of data, right? And I don't want to keep paying while I'm keep typing all of this code. So what we are doing here on this Jupyter notebook, I'm just importing some libraries like Boto3, SageMaker, and that stuff. And then I'm creating a session with SageMaker, and I use on that instance called ML M5X large. So till now, I don't have this machine running, and I'm not paying anything for this machine. I have here a sample data set, and this sample data set is, you can find the source here, cessation of income. And what we are trying to do here is to predict who's getting more than $50,000 and who is getting less than $50,000. So you can say like a binary classification model, right? But there is a lot of features, engineering that I need to do. If you can see here the data, I need to set it in a way that I can utilize it in a better thing and to matching my model. So if you see the shape of this, so it actually have 10 columns of like 10 features, 42 row. It's not big data, but it's not a big size of the data, but just in terms of, the demo here. And this is what we are doing. So we're going to be creating a Python script or a Python file that do that stuff. Like we're going to be remove any duplication. We're going to transfer the income values to two labels, either more than 50,000 or less than 50,000. We're going to do binding of the age. Binding mean like, like grouping them. Let's say if I'm from 5 to 10 years, then I would say, I don't know, I can make it them 10 years. If I'm between 35 or between 30 to 40, then instead of writing 31, 32, I just like say, it's between this range, right? Then just removing some feature that I don't need it, do hot encoding, and split my data between, training data and label and validation data set and my test data. You just simply have this one. So I have here my script. Okay. I just executed. So I create a script here. By the way, and this is why I love Jupyter Notebook lab. I open it. So I think this is the lab. Yeah. So this is the file here that we just talking about. So you find all this Python code is just written here of what we was doing. So then after that, this is here all the magic done. I just say sklearn underscore process.run, and I give it my Python script, and I pass it the session that I created on the top. So what it will do that on the fly will go and create this machine for me. If you remember, we say what? M5, yeah, M5X large. Okay, and I'm running still here on T2 small or T2 macro. I don't remember, but very tiny machine. But the job will run on the M5X large. And you run the job, you get the results, and you push the data to S3. And if you want to read the data from S3 now, because it's being saved as a CSV format, you can see that data has been transformed now. So I have down 10 rows and 73 columns. 73 columns because we did this one hot encoder, right? So for the people that they are aware about feature engineering, know about this term, right? That's it. So my data is ready now. I can start my training job, just like, get my stuff. And that's what I was telling you about in SageMaker as well. Same story. My training will happen in a different machine. Right? It just by chance here it's same size, but you can write any different size, right? So the previous machine is gone. You don't pay for it. Done. Being vanished. Now you get a new machine, M5X large. You do your training job on it, okay? Using whatever algorithm that you decided to use, let's say XGBoost or whatever, and you're done with your training. You do a model evaluations, And after you do all of that stuff of model evaluation, you decided to deploy it. Yeah, we didn't deploy it here. We just, did evaluation and later you deploy this one. Cool. So that's a pretty quick demo. I share with you the Jupyter notebook. Remember, we was talking about Amazon SageMaker processing. It's a pretty cool feature and not a lot of people talking about it. And I see it is an amazing feature. Okay, great. The other thing is experiment. Kind of quickly touch on it when I was introducing the first slide about SageMaker. But again, as I told you, one of the key things in machine learning that you try a lot. It never comes a good result from first time. You need to change your input data, generating new features, trying different algorithms, trying different hyperparameter. And there's no room for hyperparameter. It's kind of black magic for me, at least. I hope it's not black magic for you, but it's a pretty cool things that you need to keep taking notes out of that, right? Like for example, for me, I went internally for 3 days training and it was kind of hackathon. We was doing like computer vision hackathon for 3 days. I submit like 50 models and I train more than 120 times. So, and I need to compare to figure out where I kept my notes and what was the best model, what was the best hyperparameter that I used during these 3 days, right? It's quite annoying and to write down all these details. And sometimes it's a lot of details, especially if you're using complex algorithms. So here you have an experiment. So you just like run whatever you want to run. You create an experiment, put everything inside this experiment, change whatever you want to change, do whatever you want to do. We'll keep all these details for you. Then later you can group all of them and you start to visualizing and compare about all of that stuff. So that's a screenshot from the experiment and we're going to be seeing that. The idea here that you can see that I have multiple. So here I have an experiment. So I create an experiment. Inside this experiment, I have multiple of trials. So I try multiple times. Each model is having its own hyperparameter, different data, whatever you want to do, right? And then you can just simply select multiple of them and say, okay, compare this stuff for me. I need to understand who was better of this, why the performance was different, what was the hyperparameter values, what has been changed, and what was the impact on my results. And then if you are happy, just with one click, you click on one of this trial and you say deploy, and then you deploy it. So that's simply an experiment and it's really cool. By the way, I forget to mention that SageMaker Studio is currently available only in Ohio State, in Ohio region, which is in Ohio State. Yeah. So in Ohio region, so if you go to your console and didn't find SageMaker there, because SageMaker Studio, because it's only available in Ohio. Okay, let me ask you this question. How many of you, or for all the data scientists, understand what's happening inside deep learning? To be honest, very few. Yeah, very few. The problem is quite complex algorithm, right? If you see people that they are using, for example, if we take a forecast problem, there is a lot of statistical algorithm, very straight, simple equation that you can easily understand when you change a certain feature, how this have an impact on your results or impact on your model. When you get in a more neural networks, there are a lot of layers, a lot of what they call transfer learnings and that stuff. It's quite complex and it's very tough to understand what's happening there. It's very tough to debug what's happening there. And as well as it's pretty costly because sometimes you run the model and you end up by the model is not actually performing better, which we call overfitting. And you need to stop that. And we used to coding that stuff like when you see, I don't know, my F1 or my root mean square error is going down or going up or whatever, blah, 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 stop or contain. So now we launched something called Amazon Debugger. So Amazon Debugger is something is help you to understand what's happening inside your neural network. And debugger is as well help you to able to stop early, for example, if your model is not enhancing or is not providing a better, or to detect what's error that's being throwing during your debugging or during your training inside your algorithm. So there's a quite of area of research about something called SHAP, which is sharply adaptive exponentials. So that's a kind of, a libraries that you can ingest while you're doing your deep learning to try to understand and solving a problem and give you details about what's happening inside your neural network. So you can understand which feature have a better impact. It can help you to understand a very common problem in neural network called vanishing gradients, which simply by when you getting specific inputs of your data with a multiple layer of your neural network, when the signals keep going through this neural network, the signal is going weaker and weaker and weaker to the point that can be vanished and does not have an impact anymore. So all of that, Amazon SageMaker Debugger can help you to understand. And we're going to be seeing a demo about that. So that's Debugger. The other cool thing as well that we launched, I told you, right? We should change the name from reinvent to SageMaker or re-ML or re-AI. There's a lot of things that been announced, So the other thing that we announced is called Amazon SageMaker Model Monitoring, okay? That's actually a little bit different from Debugger, or actually completely different from Debugger. Don't get confused between them. So Debugger is monitoring your training during the training stage, right? Or retraining. Monitoring is monitoring your model when you deploy in production. Let me give you an example. So you put a model now for, let's say, fraud detection, right? And you are getting a transactions, or you're monitoring, I don't know, the stock market or whatever. So you have a certain features that you're receiving, and based on that, you do prediction. Now, one of the regulatory decided to add a new requirement field. So the people that they send you the data for you to analyze it, or for you, like you are analyzing it, you are receiving now some data is not fitting your model. So you need to monitor that to know that something is not going well. Or actually, it's same feature, same data you receive it, but your model is not performing well anymore. How do you know that? How you can trigger an automated action to retrain your model again to stay up to date. That's actually SageMaker monitoring. So you can simply build a baseline, and one of the key and easiest way to build a baseline, that you use a baseline of your test data. So you remember, usually when you get your data to start your ML journey, you split it to 3 data sets. So the first data set is the training data set, then the validation data sets, then there's some data that your model never sees, okay? So you pass it to it, you ensure that the model is working well, and you feel, yeah, my model never saw this data and is performing well, so let's deploy it in production. You can take this data and you pass it to SageMaker Model Monitoring to configure this one as your baseline. And if your baseline or if your model in the future start to divert or start to not performing well like your the baseline, then it starts to alert you and give you an indication that you need to retrain again. Okay, that's one of the screenshots of monitoring results, and it's quite really easy, and you're gonna be see it as well. How you can easily do that, right? So a lot of stuff so far, right? It's been like 45 minutes. We're talking about machine learning. And do you feel it's complex? Yeah, it's complex. Like let's be over, right? So it's a kind of complex topic, I can say, that's need a lot of time to digest it and that stuff. And this is why we are here, and that's why we're providing SageMaker. So that's the time of actually make your life much easier. Introducing Amazon SageMaker Autopilot. the magical, if you can say it. So simply, you get your data in. You don't need to do all what we were just saying before. You don't need to do any feature engineering. You remember when we was using a processing job to cleaning our data? You saw the crazy Jupyter notebook that I was using and showing to you that stuff. I need to use all debugging, monitoring, blah, 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 to all the things. So Autopilot is here. So simply Autopilot gets your data in a tabular format, upload it to S3, and give it to SageMaker. Autopilot, it will go through the data, understanding what is the problem that you're trying to do, cleaning the data, do a lot of feature engineering on that, try a multiple algorithm with a multiple hyperparameters. Sometimes it can train up to 40, 50 a model, and then you go and enjoy your coffee, and when you come back and say, okay, boom, this is the best trial. You remember we are doing now everything inside SageMaker Studio. So we have an experiment. So everything inside the experiment is kind of trials. You say I did like a 50, 60 trial, and this is the best recommended trial. So you can like right click, deploy in production, happy, and that stuff. So that's how it looks like, and we're gonna be see it in the demo as well. That you just simply come and do that stuff, and you have your output. The cool stuff here, and that makes SageMaker different from the other solution in the market that's doing the same by recommending for you which model to use, is there's two things. You can see here that we generate for you two Jupyter notebooks. One called Jupyter Notebook Generation Notebook, and another one called Data Exploration Notebook. So we actually generate for you Jupyter Notebook that show you what is exactly the feature engineering that we did on your data. If you click on this one, it's going to be see the demo. It will open for you a Jupyter Notebook of all the details that we're having. The other thing that it will generate for you, another Jupyter Notebook with all the proposed options that you're going to be actually, we're going to be trying it to do. The other cool feature that we are having here is you can tell SageMaker Autopilot to go all that stuff and stop here. Don't start the training job. You get these two Jupyter notebooks for you, and then you decide like you can run them as it is, or actually you can decide that you can edit some of this data and you start the training job. So this is the thing about SageMaker Autopilot. Pretty easy, and we're going to be seeing a demo. The last slide here before we're going to and the second demo is SageMaker integration with Kubernetes. So the big hype on the market about containers and how containers is actually make life for you much easier. So now we can integrate Amazon SageMaker with Kubernetes. So you can easily train and deploy your model in SageMaker with integration with Kubernetes environment. You can build a pipeline and workflow, and this is going to be a fully managed infrastructure in SageMaker, and should be saving cost as well, right? Instead of you're running a big machines, you can split your in a multiple models or whatever, right? Okay, so that's time for the second demo. So let's see. So that will be mainly focused more about SageMaker Studio. So if you remember, I told you that you're going to be here on Ohio. So remember, it's only in Ohio so far. So you come on Ohio and you click on SageMaker Studio, and you're going to find this one telling you set up SageMaker Studio. Just few clicks. It asks you about a user. You need to enter your user and create this user. And it's going to give you an URL. It can be integrated with a single sign-on as well with an SSO. So if you already, as a customer, create an AWS SSO integrated across multiple accounts, or even integrated with your local AD, that's going to be integrated of it, which is pretty cool as well, right? The security team in your side will really love it. You do one click, going to open for you SageMaker Studio. Okay. So if you see now, just like writing Jupyter. So as I told you, and it's even same logo. So that's built on the open source Jupyter Notebook Labs. So it's quite familiar interface. So if you use Labs before, it's quite familiar, almost same. And here has been split to multiple areas. So the first area here is your file. So you can organize and create a multiple folders. So for example, I create a folder here called Demo Recap. So this is the one that I put a couple of demos that going to be exploring now. And the most important thing here is the experiment. So this is the cool one that you can create an experiment and decided to do all your training job inside this experiment. Okay. So let's back here and let's see what we prepare for you. So the first thing that I prepare is actually a Jupyter notebooks that's available in SageMaker examples. And there is a quite cool YouTube demo it's being done by our ML evangelist, Julian Simon, that he is explaining this well in an amazing way, right? So you can go as well and listen to Julian. He's quite active on YouTube now. He's doing, I think, an hour daily or maybe once in a week that he stay live. If you have any question, you should go and ask him, which is pretty amazing, right? So anyway, so let's go here and click on this one. So it's gonna be open for you, Jupyter Notebook. Before that, right? Before I do this one, you remember I told you about how I can create now a Jupyter Notebook without creating an instance. I just come here and say, you know what? I want to create a new Jupyter Notebook, and I say I want to create it as a data scientist. Very fancy title, or I can use whatever, you know, MXNet, TensorFlow, PyTorch. And then I say I want to have it with Python 3, and I want to get an access to the terminal. I say, okay, just create it for me with a Python 3. So that's it. So I have my Jupyter Notebook here. I can change the kernel as well if I wish later. So I can keep doing this, do whatever I want. If this is done, I'm done with my Jupyter Notebook. I just simply come here and click on share. So it's creating a snapshots, and I can say, okay, create this one, and I get a URL that I can share it with one of my colleagues. Definitely this one should have a user in SSO to be able to access this one. So this is not a public one. Anyway, so that's very simple to create your Jupyter Notebook here. Right? Pretty easy. So let's back to this one and let's see what's the problem that we are trying to address here. So actually we're using an XGBoost. So XGBoost is like a lot of people call it like the Swiss knife. It's kind of an amazing algorithm that's used to be always winning and still winning, by the way, in Kaggle competitions. It's a pretty open source community competitions. A lot of companies go and submit a problem. I remember Netflix was submitting, I think last year, and they give an amazing award, right? And can reach to hundreds of thousands of dollars if you win the competition. So feel free and try your luck. Maybe you get all that money out of there. So what we are having here, you're going to be using XGBoost to predict if a customer for a bank will accept the marketing offer or not. We have a lot of features. It's supervised learning here. So we're going to passing to our model this data. And then we want to deploy this model and do an inference and see if actually this customer will accept our offer or not. So if he will not accept the offer, there's no need to send this offer to him to, you know, saving costs from our side. If someone going to call him, or don't get the customer based off and build more personalized stuff. So the data is available publicly. You can go and download the data. And this is the data set, as you can see it here. So it's have details about like his job, is married or not married, his education, if he get a loan before or not, if he like contact him before or not, what his salary, how long he's been a customer for us, and end of day, did he approve the offer or he didn't approve the offer. So you can expect they're going to be definitely unbalanced amount of data. Most of the people don't accept the marketing offer. But like, believe me, there is inside this data some people who accept the offer. So you see what we are trying to predict here is why, right? Why it means if it's no, it means that he didn't accept the marketing offer from the bank. Yes, it means that he accept the offer, right? So if you can see here, we have 24 column, which we call it features. And we have, I don't know how much this number is. It's 41,000 or 4,000. I don't know. 41,000. So I'm sharing a screen. So I need to wear my glasses anyway. So it's 41,000 inside our data set. And you can see, see the people who say yes is a 4,640 and the negative is 36,000, right? So it's pretty unbalanced data. So a lot of feature engineering that you need to do, right? So a lot of transformation in our data set that we need to do. We need to remove some feature. We need to do one-hot encoding. And then after all that, you can see how our data looks like. Then I need to split my data. And after I split my data, I need to start my training job, as you can see here. So in the training job, like we saw in the other Jupyter notebook, we define our algorithm. We are using here XGBoost. And actually, we decided to use a machine M4 2x large here, as you see it here. So this is the machine that we can decide to use. And with an amazing thing from SageMaker, all what you just need to do is say XGBoost.fit and pointing to your data set, and all the training job will start. So the training job will go on. And after the training job is done, and I'm happy with my results. As you see here, my training and validations, it's not like big, good accuracy, but it's like, just for demo. So my data is here and I'm happy with that. I can decide to deploy. Simply, I decide how many machines I want to deploy and what is the size of this machine. And I just simply call XGBoost to deploy. I'm going to deploy my model. And once my model has been deployed, I can do like a batch job, or I can do an inference as an online inference, where I can pass my data and get the results. So pretty cool, right? It's very straightforward. A lot of details on that and a lot of feature engineering and data. But as you see here, right, like we done everything in one place, right? Even we, bring up a couple of machines in the back end to do all that stuff. But, we did this here in a simple way. I think it is something as well cool that I need to show you here is during, included on this one or not? Yeah, you see this one, see this area. So we define here the new feature, which we call debug, right? So all you need to do is you add this snippet of the code here to tell them that I want to do debugging and I want to get all the metrics of my debugging here, right? And I define a rule. So you can define a bunch of rules, right? So you can say if, I don't know, if my F1 or if my root mean square error goes down, just stop. Or I can just simply, like what I'm doing here, I'm collecting metrics. And as you see here, like when I did the training, there's two things happening at the same time. The training is being done and the logs is being thrown in S3 and debugger is analyzing that stuff now. And, if you check the debug states that say actually it's monitor all tensors. Tensor is like, fancy name of matrices, like, or that's just, they call it tensors, and that's why they call it TensorFlow. And for that, like, we don't have any issue on this one. Like the debuggers didn't capture anything. It's quite cool. Everything is fine. We don't have any issues. The metrics, I can see them here, and there is no issue. So this is how you add a debugger here. So once this has been trained and deployed and you're happy, you maybe think how I can enhance it better, right? To enhance this better, you need to do auto hyperparameters. Hyperparameter is something you need to define before you starting the training job. Unfortunately, you cannot change this during your training job. You have to do this before, because this is impact the equation or the algorithm that you're going to be using on this training job. So far, we did the feature engineering, we cleaned the data, we train, we get the results, we did the debugger, but we're still not happy. So we need to do some auto hyperparameters. So the good thing that this is the same data set, but there's another Jupyter notebook. So that's the same thing we did last time, selecting the data, reading the data, blah, blah, blah. The only difference that we did here is we defining that and instead of imagine, right, if I want to try to do a multiple hyperparameter, let's say from here, from 1 to 10, that means that I need to run this Jupyter notebook that we ran last time 10 times. And every time I will change the hyperparameter. And I need to write all this down because I need to compare the result later. So likely SageMaker, and this we had it from last year, that you can give it a range of hyperparameter until it just go and do hyperparameter tuning. So it will run a multiple job for you and it will tell you which model was better. So I run this Jupyter notebook because it took around 2 or 3 hours to run because we trained multiple times. And if you go for SageMaker here, and if you go under training, there's a very interesting something called, rather than the training job, there is something called hyperparameter tuning jobs. And this is the job that I run today. You see how many job that I run? I run this time 40 times, and there is another one that I ran an hour back. I run my Jupyter notebook 250 times. Think about it. If you want to capture all the changes in the 250 time of your experiment, that's crazy, right? And it's very, very tough things to do. And that's why SageMaker and experiment is a fantastic option for you here. Anyway, you see, we run here 40 times. And I can see here the objective metrics of all of this that I decided to do. And the cool things that under SageMaker hyperparameter job, we have the best training job is here. That's being selected for me by SageMaker. And I can see here all the details of that. What was my hyperparameter that I utilized? Okay? So imagine all of this I need to do just to predict if someone will accept my offer or not. Right? Lot of stuff to do, right? Looks crazy. So now let's think how we can easily do that, right? I don't want to do all this stuff. I don't want to waste my life, waste my time. It's a good weather now in Dubai, so you can go and enjoy the beach side, stay taking your coffee, enjoying the sun, and get all the stuff run for you. I can do that, and I don't want to do all that stuff. Again, I'm gonna back to SageMaker Studio. So I just simply gonna come here. Oops, we're still in the demo, right? Wait, yeah. What? Happening? Yeah. Come on. Oops. So yeah, I need to swipe. This one is, it keeps swiping here.
A laptop get tired.
Yeah, here we go. Okay. So it's pretty cool. No, you need to see this one. Do you still have people live or people is like gone?
We have 6 survivors.
Okay, cool. Each one of you is have a special gift from my side.
The heroes.
Oh, okay, yeah. So that's a pretty cool one, right? See what you're going to do now, right? I'm going to create an experiment. I'm going to use the same data set that I used it before, that we use it here, right? Just a second, I'm going to get the path of my data set. So I just upload this data set to an S3 path. This is my S3 here. S3. So yeah, oops. Yeah, so this is where my data set is. And remember, same data set, right? So we're going to be using the same data set that we had it before, and we try to predict why, right? And I don't want to do anything, right? I don't want to do feature engineering. I don't want to do anything. I just simply come here and I click on create experiment, and I will say it 6 hero in the call. Okay, great. So I'm gonna put this my data set here, and here is asking you a very cool question, right? What is the item or like your target value, which means what you're trying to predict. What is the field that you try to predict? Let's say I want to predict Y, which is say that if the people have accepted the offer or not. And then I come here and say, okay, give me the output of my artifacts under this one. Okay, and then I can tell him, just one space. Yeah. So then it's asked me like, what is the algorithm they want to use? To use a binary classification, linear regression, multi-class classifications? I don't know. I don't have time for that. I just want to go and relax. So I just say auto, and then I come here and say, okay, that's a cool thing. Do you want me to explore the data and generate for you the 2 interesting notebook instance? Or you just simply you want me as well, after exploring them as well, to train the model. So say, okay, train as well. So I do this here and say click experiment. That's it. So go enjoy. That actually gonna train and try, as you saw here, which I did it before the call, 250 times. 250 times that you need to change something, and you keep record all that stuff, and then you figure out what's the best one for you. That's actually what we did here, right? So it will keep going, okay? But we had one before. This is because this is going to take a long time. So currently it's analyzing the data. Then it will do the feature engineering. Then it will train. Then it will get it ready for you. I did that. So I have this here. I did it 11 hours back. Get it in a better way. So I can come here and I say, describe my AutoML. Can you see? I have here those 2 amazing Jupyter notebooks. Let's open the first one. See the magic, you know, very well organized Jupyter notebook for you. Have this as a starting point. Very well documented. If you want to change anything, generate those and change whatever you want to do. And it's very well written in a nice way. So it's saying, oh, I need your data, I need your data, I found this number of columns, I found this number of rows. And you know what? You try to predict something called Y. You can just edit this one and you call it, I don't know, accepting conference or whatever. And you see it is exploring the data set same way that's usually the data scientists do. Then it's analyzing and say, you know what? Looks like it's like a binary classification thing, right? So I'm going to be using that, right? And it's giving you here a recommendation and action items to do. Yeah, it's looking if there is any values missing, how many columns on that, as well as being doing some statistics about that, which is pretty cool. Usually data scientists do that, right? What's median, what's mean, what's the minimum, what's the maximum. And then just explore the data. That's pretty cool, right? That's usually, maybe take from you, I don't know, if you are like a good practitioner data scientist, maybe take from you 2 hours or something, just save them. If you're new for that and you want to write it in, maybe take like, yeah, if you're like a poor guy like me, it can maybe take you from a week or 2 weeks. I know it's like my poor knowledge, you get all that stuff in a long time. So anyway, so you've done that, then you get, this is an amazing one, right? Look to this one, right? Tell you SageMaker Autopilot candidates. Candidates mean the recommended or the recommended algorithm with hyperparameter that we're going to be using. So it download the data after we clean it up in the last one, and we recommend for you a candidate pipelines. So the first one, XGBoost, yeah, it's classification. So makes sense to use XGBoost. with a version called DBB0, a specific hyperparameter, DBB1, different hyperparameter, and 2, and 3, and 4, and 5, 6, 7. So see all of these things that he will try. 9, as well as he will select one of them, and he start to build the pipeline. And then he will do as well AutoML with a hyperparameter tuning as well, right? So it's based on the knowledge that we have. We're going to use with the multi-algo jobs that we have and above a multiple hyperparameter. And this is why we end up here, when you saw that, by we having 250 trials. Pretty cool, right? So yeah, saving a lot of time. I have Muhammad Azzat here in the room as like is so impressed with that. I'm impressed as well when I saw it. Like really amazing, right? So once you finish this one, you can deploy as well. Like see the same thing that we used to write, right? You remember I waste your time for the last half an hour, and I'm quite sure that still what this crazy guy is saying, right? That's you can do it in one click. Here you go. This is there. Still more impressive stuff. We run this one, right? And we said we ran 250 trial, right? So where is this trial? Where I can see all this trial then. So this is all my trials. This is all the trial that I have. How I know what happened between them, how I can compare them. Just simply, you can select one. First of all, I can just filter and say, I need only the training job because I have here a different job. You remember processing? Anyone start to see processing? We're using processing here. So we're quite advanced from what we are using in what we are releasing, right? We are using what we release. So let's say I select all of those and say, okay, I decided to see why here my metrics was 0.9 and here it was 0.6. What happened, right? So I select that and then say add charts. Pretty amazing, guys. So I click here and say add charts. I say I want to have summary of statistics. I want to see scattered pull charts. And let's say I want to compare with a hyperparameter. So we have alpha and I have gamma. Couple of crazy hyperparameters. And I see by the number of trials. So let's see, we're going to get something. Okay. So I get this, like a comparison between all my models on scattered charts. Okay, I don't know if I make it like a bar chart or histogram, it will get something, you know. So you keep playing, understanding what's happening between all of them and what actually you are trying to understand. It's like pretty easy to select that stuff, right? It's a pretty amazing thing, and that's what we call experiment. Okay. We still have 15 minutes, and I have a lot of cool stuff to show you, but. Quick thing, yeah, we still have an AI services. We didn't touch on AI services, but quickly, guys, we didn't discuss monitoring. So monitoring is a quite cool thing, and it's very easy to do. So this is a Jupyter notebook for monitoring. You remember monitoring, we say after we do all that stuff, we want to deploy it in production, and we need to ensure that our model is working fine. So it's quite similar to that we did before. Just the only thing that you do here different, that you defined okay, that's I'm deploying this one, yeah, that you define here, or you're importing a model called monitoring, and then you tell monitoring what is the sample, or what is the percentage of the sample of the data that you want to capture. So here I'm capturing 100% of my data, right? And I'm getting all this data, and this is actually what I'm getting, that's what I'm capturing. I'm throwing in F3. That's what the data is sending. So this is my feature, as you see here. This is all my features sending to me, and that's the output of my model after the inference, okay? And I keep monitoring. So I get a lot of, you know, I'm just like, keep listening until I receive something. And then I can see that all the stuff that I was listening to, the monitoring was telling me that it's completed with a validation. So there is nothing as an issue. Usually monitoring will tell you it's completing with violations or no violations. So here I have some violations and I have like 60 violations. So that can trigger Lambda function to retrain my model, right? Or you can say it's failed, which means that execution has been failed during like a client error or sending an undefined data, or the shop has been stopped. So I'm going to share this Jupyter notebook. Again, it's available in examples, but it's quite easy to implement. Okay. So that was, I will not say quick because it was not quick demo, but that was a good like demo about all what it be launching on the SageMaker, right? Till we launch a lot of stuff in AI services. Just for you to remember, if you're still there, still 6 survivors. Okay, cool.
6 years.
6 years.
Sharif and Sameer.
Great. Okay. So guys, what we are having here is AI services. So we launched a couple of cool AI services and we enhance as well a couple of them pre-reinvent. So for example, for comprehend, we had 6 languages. Translate, we had 22 language. Transcribe, we had 15 language. And Lex become an HIPAA standard. Personalize is add something called batch recommendation. And forecast now is supporting multiple quantiles, which is allow you to do an P10, P20, P30, whatever you want to do. You know, if this Chinese for you, forget about it. It's just a couple of updates that we did. One of the cool shit here that we released, and it's still in purview, it's called fraud detector. If you don't want to do all what is show you in the SageMaker, you kind of want to do something like autopilot, you can use this service. Just simply get your data in S3 in a tabular format, simply CSV, Excel sheet, upload it there. What we're gonna do, kind of autopilot, where we do data validations, we're examining the data, do a feature engineering, choosing the model for you, and measure the performance and deploy it and give you endpoint. And just simply you can use this fraud detection in a multiple scenarios. Like if you wanna configure if this customer is a new customer or is a fraud, right? There is a lot of people, maybe like me, or I don't know, like someone is like, you know, I try always to try and use the free stuff at the beginning, right? Like a free service every time you want to get the first time. So give a different name, you give a different email to get the first trial for free, right? So you want to detect that, right? You don't only detect the really new people, not the people trying to be smart. If you want to do like a payment fraud, like very common scenario, if you want to detect if the customer, it's a real guest or like a fraud customer, a lot of people is like try before you buy. So they keep trying before they buying and they never buy. So you want to detect all of this, and Amazon fraud can do it for you. So it's like, for example, you detect your IP, you detect your email, detect your card, and based on that, we send it to fraud detector and tell you if it's fraud or not. Pretty cool service, similar like personalized, similar to like forecast. Simply just with one click been using it, right? The next one is transcribe. So transcribe has been for a while. It's converting voice to text. What has been launched in as a GA in reinvent is we do this for medical. Pretty focus and train. Actually, currently we're supporting US English. So it's good because like most of the doctors can definitely say this in English. So we can be easily using that. It's very affordable. It's like 7 cents per minute. So it's quite reasonable cost for such an amazing service. The other cool demo is I was actually preparing for you guys is Amazon recognition custom label, right? You remember Ground Truth in SageMaker? One of the events, someone actually came to me and said, if Ground Truth is smart enough to do self-labeling, why actually doesn't be converted to a service? And I looked to him and said, like, that's smart. And we have it here, right? So you go now to Amazon recognition, get your data, and you label it. You just simply label it with a couple of 5-6 photos because we do a lot of transfer learning. And then you being trained on that, and you can head this API and you get your results of that. So it's just simply importing your data and train your model, and you give you an API. very quick. Let me show you a quick demo on that. So you remember when we talk about the Sea Dragon? This is why we have Sea Dragon, right? So I create a project. I don't know if you still remember. So I create a project here called Sea Dragon. So that's my data set. Let me show you the data set first. So I upload like 10 images of the Sea Dragon.
And you said he tried it with a camel photo and he gave him a dog.
Yeah. So if you go for if you go for recognition itself, if you go for recognition, let's go for recognition and simply try to upload one of the photos of the Sea Dragon, right? And upload the photo, go my desktop, my favorite creatures, Sea Dragon, and let's say we're gonna do this one. So recognition did a great thing, right? Say it's an animal, it's a sea life, that's great. It's maybe mammals, it's not a mammal for sure, and it's not a shark for sure. It's kind of fish, right? But that's what, I don't need that, right? I wanna get a Sea Dragon and say, that's a Sea Dragon, right? So simply what I did is I came here and I create a data set, right? I came here and I create a data set, and then I say, I wanna do a training labeling job. So I say, start labeling, and I select this one and say, draw bounding boxes. So I came here simply, and I start to label this as a Sea Dragon, as you see here, right? Like that, as simple as that. And I say, okay, done with my labeling. I'm done with my labeling. Then what I do after that, I can come here and I come to my project and I say, I want to create I come to my project that I have and I say, I want to create a new training for my model. So I want to create a new training model. I'm going to choose my data set that I define. I tell them split it between training data set and my test data. And that's simply click train. It will take some time until be trained. And you're going to have this, sorry, let's go back, like this one that I trained before. And I trained this before, okay, and I'm get a great results, like, my data sets. And I can say, like, view my tests. And you can see here, it said, that's my data set that I uploaded for testing, or that's been split or testing. Say this is 33% is a fish, 68 is this one. So let's try to get a photo now and try it. To say like Sea Dragon and get a nice photo of that, of the Sea Dragon. Let's get this nice one. And I say save as an image. And I go to my desktop and I see Dragon. And I will call this one is test 2. Right? So simply, I need just to upload test 2 here to just 1 second. I'm gonna get my remember this one. What was my bucket name? So this is my bucket name. It is, this is the name. So I back here. Okay. And I'm gonna be uploading my image under test. Gonna be uploading my image, which is this, whoops, not this one. File, and I'm gonna call it test 2. Okay, gonna be uploaded here. And all I just need to do now is I get my CLI. And I hit recognition. Ooh. Okay. And I run this one. Hopefully you can see. So simply, that I'm hitting here, as you can see, and I explain this for you now. So I'm hitting here recognition, a custom label. I'm giving my ARN of my trained model, or like my endpoint, and I give it my S3 buckets that have my this informations and the region, and say this is instance 2. And this is gonna go and hit my ABI and set the Seadragon by percentage of 42%. Okay, it definitely can take it as a fish, but it's not good model because I train only on 10. But that's simply how you can do that, right? So we have 3 minutes. So maybe I get extending a little bit more, but not much. So another cool service we generate is called Kindra. So you see, when you go and do search inside your organization, it's quite complex to do an enterprise search because usually you have a different data sources and you're searching in your data is quite crazy, taking long time. You receive a lot of internal URLs. That's quite complex to receive a result from. So we launched a service called Kindra. So Kindra is using NLP to analyze an understanding of your data sources. And based on that, we are doing a couple of stuff, right? So we can do a neural network queries. So instead of you are, let's say, searching about where's my IT room, so instead of you get your URL, it will tell you that IT room is on the first floor, this area. What is the price of, I don't know, changing my tickets? So give you the answer directly, all that stuff. So we do this in a neural network, natural language query. We do this as well in natural language understanding. And we have a lot of domain expertise that we added. We add 16 major domain expertise between pharma, FSI, IT, and that stuff. Going fast because of the time. So that's an example, like you say, where is the IT support room? Tell you in the first floor. How long I can take my maternity leave, say 14 weeks, all that stuff, right? So we have a connector for multiple data sources, S3, Box, so SharePoint, databases, OneDrive. So currently, it's not all of them is live. We have only supported 3 data sources so far, which I'll show you now quickly. But remember, Kindra is very simple to do. Okay, so the first step, you upload your data. Sorry, first step, you create something called index. So you define that you have an index, which we generate the AI service in the back end for you. Okay. Then you choose your data sources. So there's SharePoint, Salesforce, whatever. In my demo, I use S3. And the last thing, you get the console that you can just simply go and search it. So let me show you last demo and last minute, and then we'll end this machine learning night, if you can say. So that's my Kindra. So simply what I did is in my S3 bucket, here I create a bucket. I call it Kindra. So I went to Amazon.com and I downloaded some HTML pages, like, you know, what will be the cost of refund, how I can deal with Kindle and all that stuff, just HTML pages. Then I back to my Kindra. And the first step I did in Kindra, I click on create an index. I just give it a name, it choose my role, that's it. It takes like 5 minutes until I get my index ready. And then inside my index, I came here and I click on data sources and I say add a data source. So as you see here, it's only 3, right? The slides say a lot of stuff, but still it's under technical purview. So you need to request an access and you'll get the same thing. So I have an S3 buckets, I have a SharePoint, and I have an RDS. What I choose as my data source, as I told you, as an S3. Very simple, no magic at all. I specify my S3, as you can see here. You know, just give it a name, specify my S3, that's it. There is some metadata as well if you want to add a lot of metadata if you wish. You can specify how often your Kindra should go and pull and crawl the data and all that stuff. That's it. Once you're done, you get this interface. So in this interface, I can just simply write like a return. Let me search about return a Kindle book, for example. Well, it will go and search and everything, and you see I get the results here, right? And if I click on that, it will take me to the source page that I uploaded in my S3, right? There's no images, and this is why it's not looks fancy Amazon page. I downloaded in my laptop, then uploaded to S3. The other cool things that I was telling you about, it can get you the answer directly. To say, what is the annual fee for, let's say, Amazon Prime? Let's say a lot of people is asking this question, right? So you see, you get the answer directly. I see 119, and that's the source of it. It's a pretty cool service, very easy to use, right? And you don't need to do a lot of stuff, right? Anyway, that was the last demo. There is another service called Amazon Augmented AI. That's actually like ground truth, but instead of using to label the data before the trainings, that you use it to build a human workflow to review the accuracy of your model after you deploying it, right? So it's same story like ground truth, but actually after you deploy to ensure of your data accuracy, send it to things like mechanical tasks, and you get your response out of it, right? There is something called product in Amazon called Amazon Connect, which is our call center as well. We release a service called Connect Lens, which is actually a bunch of multiple AI services like transcribe, comprehend, translate, and put it for you in a nice interface that you see here on the screen. So while the people is talking to the call center, we detect all that stuff, and actually we give you a nice dashboard. So the supervisor on the shift maybe jump in and help before a problem happened and escalated from the call centers. There was another service called AWS Code Guru. We're running out of time by 3 minutes now, but simply Code Guru is help you to detect what's going wrong in your code and giving you a recommendation using an AI and deep learning as well. So it's a pretty cool service. Maybe I was actually planning a demo for that, but definitely we're running out of time, so maybe do later. Last things, Amazon as well is keep releasing devices every year to help you to apply machine learning. We know that maybe kind of new machine learning things is tough to be utilized in a real life. So last year we released the Bracer to help you to do like a reinforcement learning and become more lazy, more relaxed, and writing less line of code by doing something called rewarding function. This year we released a new enhanced version of the Bracer, which is called the Bracer Evo, which is actually have 2 cameras, so you can have head-to-head race, which is pretty cool. It should be there in summits, and as well you can compete online, because of whatever situation happening now globally, as you know, viruses and that stuff. You can still compete online, build your model. We're doing one competition every month. We're gonna have 22 winners. They go fully funded to reinvent. It's running an Intel inside. Yeah, it's not time to run the video. It's a pretty cool video. You can see it online. In reinvent as well, we launched something called Deep Composer, which is using something called generative AI. So it's kind of you are building something, giving to an AI model, and we actually generate something similar or contain what you're playing. So imagine in the future, maybe we get all the Mozart concerts and give it to Deep Composer, and Deep Composer can keep generating for us a new note that he never played. Or in Arabic region, we get Kalthum, for example, and then we hear to a new song for Kalthum that she never sang before, right? So things you never know that can be happen. Anyway, so with that, I want to thank you for the night. So sorry for 6 minutes over. I hope you enjoyed. I know there's a lot of information. Only, if one thing you need to know about that is Autopilot is awesome. SageMaker Studio is an amazing. Kindra is a great service, and AWS is awesome. Thank you, guys.
We have a question from Muhammad.
Yep.
Muhammad Qasim.
Yeah.
So the question is there any services for personal statistics like A/B test and Nova?
If you can send me an email with that, and let's discuss that offline, because we actually running over time, and it's actually 10:30 here in Dubai. So my email on the screen, please feel free to send me an email and we can get in touch with you. Okay. So thanks, guys. Appreciate you staying with us till the night. Special award will go for you. Okay. Thank you. Have a great night.